Hello, this is the second part of Module 2, which covers Python basics. Let's now talk about how Python implements loops, beginning with what we call counted loops, which are repetitive code that runs a predefined number of times. Counted loops, as the name suggests, uses a counter variable. In Python, the values that a loop counter variable can assume can be defined by a function called range. In its simplest form, the range function accepts a stop value, meaning that the counter variable will assume numbers from 0 to stop minus 1. Let's use an example to clarify exactly how that works. Practice problem number 5 wants you to write a program that asks the user to enter their name. The program should then display the name entered exactly 10 times. Name your program as show name 10 times. The first line of the program has the input statement. The name of the user will be saved in a variable called name. Then the counted loop defines a counter variable named underscore that at each loop iteration will take a value generated by the range function. Range with stop equals to 10 means that underscore will take values beginning at 0 and then 1, 2 until 9. In this example, we are not particularly interested in the exact values assumed by the counted loop variable. That's why we named it with underscore. The output shows the name entered by the user 10 times based on the instruction inside the loop, which prints the input name. Because that instruction will be executed exactly 10 times, the output will show the name 10 times. Now let's consider another example where we actually care about the counter variable because we want to print it. The problem description says, write a program that asks the user to enter a non-negative number. The program should then display all the non-negative numbers that are less than the given number. For example, if the number entered is 5, the program should display 0, 1, 2, 3, and 4. Which value do you think we should use for range stop parameter this time? Think about it. Use less than number as the name of your program. The solution begins by reading a number from the user. Then it uses a conditional statement to perform what we call validation, a simple check whether the number entered was actually a non-negative number. If the number is negative, the program will just display an error message. On the other hand, if the given number is in fact non-negative, the program proceeds and runs a counted loop using the provided number, saved in a variable named n. Note that n was used as the stop parameter for range. As mentioned earlier, this time we are interested in using the counter variable named x inside the loop because the values that will be assigned to x are the actual values we want to print. Python range function is very flexible and accepts more than one parameter to perform more complex range of values. In this next example, we want to write a program that asks the user to enter two integer numbers, a and b. The program should then display all the numbers from a to less than b. For example, if a is 3 and b is 10, the program should display 3, 4, 5, 6, 7, 8, and 9. You can name this program print range this time. When the range function is given two parameters, the first one is the start value, and the second one is assumed to be the stop value. So the solution uses range a, b to print the desired output. The previous example didn't print the value of b because we use b as the stop value for range. What if we want a closed interval? In other words, we want the same output as previously, but also including b. Modify print range to display all the numbers from a to b. For example, if a is 3 and b is 10, the program should display 3, 4, 5, 6, 7, 8, 9, and 10. Well, the solution is pretty simple. You just need to define the stop value for range using the expression b plus 1. The past examples assumed that the step between the numbers was 1. What if we want to jump the counter using a different step value? Modify print range one more time to display all the numbers from A to B, but use an increment step of 2 now. For example, if A is 3 and B is 10, the program should display 3, 5, 7, and 9. When range has 3 parameters, the first one is assumed to be the start value, the second one, the stop, and the third one is the step value. In our example, we're using a step value of 2. Pause the video now and try to implement this one on your own. Try to compute the factorial of a given non-negative number n, denoted as n exclamation, and defined by the product shown on the screen. For example, the factorial of 5 is 5 times 4 times 3 times 2 times 1, which equals to 120. The factorial of 0 is 1 by definition. Name your program factorial. Now compare the solution displayed here with your own solution. Because we want to accumulate the factorial, which is a product, we initialize the factorial variable with 1, which is the neutral value of the multiplication. Our solution uses n as the start, 0 as the stop, and negative 1 as the step. For example, if n is 5, that range will generate the values 5, 4, 3, 2, and 1, stopping at 1 right before 0, the stop value. The x counter variable will assume those values generated by range, and their product will be accumulated using the factorial variable. At the end of the loop, the factorial of the given number will be displayed. Sometimes we want to run a loop as long as an expression is evaluated to true. In those cases, Python provides the while loop statement. To illustrate how while loops work, write a program that adds all the numbers entered by the user until the number entered is 0. A while loop is more appropriate for this type of problem because we can't tell ahead of time how many numbers will be entered. Name your program simple summation this time. The solution has the user enter the first number, saying it using a variable named x. This variable is used to initialize variable s, which will accumulate all values entered. The loop condition expression is x different than 0. In other words, as long as x is different than 0, the loop continues. At each iteration of the loop, a new number will be read in x, and that value will be accumulated in s to perform a simple summation of the input values. The loop finishes when the user enters 0. When that happens, x is not different than 0 anymore, and the loop control expression is evaluated to false. The last statement of the program prints the result of the summation, the value of s. The last topic we want to discuss in this module is lists. A list is a collection of values. Take the list fruits, for example, that has 4 fruits defined as string literals. Python provides the len function that returns the number of elements in a list. Lists are indexed. The first element of a list can be retrieved using index 0. The second one, index 1, and so on. The last fruit in the example could have been retrieved using fruits index 3. But we can also use negative indices in Python, with negative 1 representing the last element of a list. Finally, the example shows a simple way to iterate over the elements of a list. The next problem illustrates how to perform a simple search on a list. Write a program that asks the user for the name of a fruit to search for. If the fruit is in the list, consider the same list from the previous example, your program should say fruit is available. Otherwise, the program should just print fruit not found. You can name this program fruit search. The solution shows how to perform the search using a conditional statement with the in operator. And this concludes the second module of our course. In the next module, you will learn how to work with libraries in Python. Goodbye for now.